Okay, now we're going to solve question 16, and we're going to use the same process we used for 15. And again, anytime in geometry you're struggling with a problem, you want to look at the given information and make a diagram. Just get it on paper. When you get it on paper, sometimes things just happen to open up and make more sense. That's what we're going to do. So let's read along. It says, let Q be in the interior of angle POR. Let point Q be in the interior of angle POR. So we want to get on paper angle POR. We want point Q to be on the interior. Okay, so we've got the first part. Now it says using angle addition postulate. Okay, the angle addition postulate, just like the segment addition postulate in very basic terms, is part plus part equals whole, and we're going to use that to solve for x. It does want us to find the measure of each angle, which after we do that, we want to plug that in to check anyway, so we'll do that. Okay, now over here on 16, it says the measure of angle POQ is 1/3 x plus 1/3. We don't have angle POX drawn, but we do have point Q, I don't know why I'm saying x. POQ, so let's go ahead and draw that. Angle POQ, and its measure was 1/3 x plus 1/3. Hopefully you can see that's part of the larger angle. Let's go back to the worksheet. The measure of angle QOR is 2x plus 4/3 degrees. So the measure of angle QOR is 2x plus 4/3 degrees. Angle QOR is 2x plus 4/3 degrees. Again, hopefully you would agree that this is a part. The last thing we look at is the measure of angle POR is 5x minus 1 degrees. Angle POR is this entire thing, POR. And this whole thing measures 5x minus 1 degree. So part plus part equals whole. So according to the angle addition postulate, we have 1/3 x plus 1/3 plus 2x plus 4/3 equals 5x minus 1. Part plus part equals whole. So we're going to combine like terms. 1/3 x plus 2x is, this will write, 2 and 1/3 x. 1/3 plus 4/3. We can add these fractions because we have a common denominator. We add the numerators. We keep the common denominator, and we get 5/3 equals 5x minus 1. On this particular problem, I'm going to subtract the 2 and 1/3 x. I could subtract the 5x, but I'm just going to keep the x positive. I'm also going to add 1, so I can isolate the x. This is gone, and so is this. I'm left with, okay, 5/3 is equivalent to 1 2/3. 1 2/3 plus 1 is 2 2/3 equals 5 minus 2 1/3 is 2 2/3. Normally before trying to divide this, I would convert to an improper fraction, but because I noticed that this coefficient is equal to this constant, I know that when I divide in order to isolate x, that 2 2/3 divided by itself is always 1. So 1 equals x. Now I do want to plug in to make sure that this is correct. 5 times 1 minus 1, okay, is 5 minus 1 is 4, so that's 4 degrees. Here we have 2 times 1 plus 4/3. 2 plus 1 1/3 is 3 1/3 degrees. Here we have 1/3 times 1 plus 1/3. We have 2/3 degrees. 2/3 of a degree plus 3 1/3 of a degree is equal to 4 degrees. And that checks out, and that's the correct answer.